Those orange streaks across Starship's belly during the last two V2 flights, they weren't just spectacular, they were warning signs. Coolant leaks, oxidation damage, tiles that couldn't handle the heat. SpaceX new V2's heat shield had serious problems. Now, Ship 39 has rolled out with something completely different. The tiles look tighter, smoother, more uniform than anything we've seen before. Could this be the breakthrough that finally enables true rapid reusability? Welcome to Space Update 24 Hours. Let's dive right in. The transition from V2 to V3 isn't just another iteration. It's SpaceX admitting that the previous design had fundamental flaws that couldn't be patched up with minor fixes. When Ship 37 and Ship 38 completed their missions, the engineering team didn't celebrate for long. They had video evidence of exactly what went wrong, frame by frame, tile by tile. The white streaks told one story. Coolant was escaping through gaps that were supposed to be sealed. The orange discoloration told another. Those metallic test tiles were oxidizing under extreme heat, reacting with the very coolant meant to protect them. Together, these problems created a heat shield that worked well enough for test flights but would never support the rapid reuse cadence SpaceX needs. How do you build a Mars transportation system when every vehicle needs weeks of tile replacement after a single flight? That's where Ship 39 changes everything. The first clue appeared weeks ago when observers spotted the sections rolling toward Megabay 2. People who'd been watching every Starship build immediately noticed something different. The tile surfaces looked cleaner, more uniform. The gaps between tiles had shrunk dramatically. The bonding material connecting everything appeared thicker, more consistent, like SpaceX had fundamentally rethought how these pieces fit together. Then Ship 39 was fully stacked and the full picture emerged. This wasn't a heat shield with incremental improvements. This was a complete redesign. Every section showed the same careful attention, the same tight tolerances, the same polished finish. For the first time, we're looking at what SpaceX believes is the final form, not another test iteration. But what exactly changed? Let's break down the 5 major upgrades. First, completeness. Ship 39 appears to carry a full, uninterrupted tile set covering the entire reentry surface. Previous vehicles had deliberate gaps, test sections with metallic tiles, areas left exposed to gather data. Those days are over. V3 represents the first time SpaceX will evaluate the heat shield as a complete system, performing exactly as it would on an operational mission. A few spots might look incomplete right now, but those are simply areas where installation is still in progress. The design itself is finished. Second, the tiles themselves have been completely redesigned. Elon Musk confirmed that V3 incorporates new tile compositions, likely stronger materials, possibly new elements that resist cracking during the most intense heating phases. These aren't the same tiles with better glue. These are fundamentally different protective elements engineered to survive conditions that damage their predecessors. Will they hold up when plasma temperatures exceed 2,600 degrees Fahrenheit during re-entry? Third, the attachment system has evolved. Tile loss was a genuine risk on earlier flights, especially when extreme vibration combined with thermal expansion. The new mounting design needs to secure tiles firmly while allowing them to expand and contract as temperatures swing from cryogenic cold at launch to scorching heat during re-entry. It's a mechanical challenge that requires precision engineering. Too rigid and tiles crack. Too loose and they detach completely. Fourth, gap management. During Flight 11, SpaceX tested the crunch wrap solution, an approach to minimize spacing between tiles. The results showed promise but weren't perfect. V3 almost certainly uses an evolved version that seals these critical gaps more effectively. Those white streaks on V2 weren't just cosmetic problems. They were coolant breaches that indicated heat was penetrating through gaps into the active cooling layer beneath. If V3 solves this, it solves one of the 2 biggest threats to tile integrity. Fifth, and perhaps most visually striking, are the reinforced corner bonds. Look closely at Ship 39's tile layout, and you'll see small white filler points where 3 tiles meet. These reinforced bonding materials eliminate micro gaps that previously allowed superheated plasma to reach the cooling structure underneath. It seems like a minor detail, but these tiny vulnerabilities were responsible for some of the most visible damage on V2 flights. Fixing them could mean the difference between a heat shield that survives and one that excels. These upgrades collectively represent something bigger than improved hardware. They represent SpaceX's pathway to true operational reusability. Not the we can reuse it after extensive refurbishment kind, the catch it, inspect it, fly it again within days kind. That's the actual goal here, and it's worth understanding why this matters so much. Falcon 9 proved you could recover and reuse a rocket booster. That was revolutionary. But Falcon's second stage is still expendable, which means every launch still throws away significant hardware. Starship aims to change that equation entirely by recovering both stages. Booster caught by Mechazilla, ship returning intact for its own catch. When that system works reliably, launch costs drop to levels that make Mars missions economically feasible. Not just technically possible. But here's the constraint. Recovery only matters if refurbishment is fast. If SpaceX catches Ship 39 perfectly, but then spends 6 weeks replacing damaged tiles, they haven't achieved operational reusability. They've just created an expensive maintenance cycle. The heat shield has to perform so well that post-flight work becomes routine inspection rather than major repair. Can V3 actually deliver that level of performance? We're about to find out. Ship 39 is now entering its final pre-flight testing phase. Cryogenic testing comes first, exposing the heat shield to extremely low temperatures to verify that tiles remain bonded and stable when the tanks are loaded with propellant chilled to negative 297 degrees Fahrenheit. Then comes the static fire, which subjects the vehicle to intense vibration and acoustic pressure. These tests could begin as early as late December and continue into January. Then Flight 12 happens, currently targeting a January launch, and V3 faces the ultimate test. Not a simulation, not a ground test, but actual atmospheric reentry with real plasma, real aerodynamic forces, real heating that peaks around 2,600 degrees on the windward surfaces. Every upgrade will be validated or exposed. Every design decision will prove correct or reveal new problems. This is the flight that determines whether SpaceX has actually solved the heat shield challenge or simply delayed it another generation. But even if V3 performs flawlessly, the work isn't finished. Elon Musk has repeatedly identified the heat shield as one of the 2 remaining major challenges for sustained multiplanetary operations, the other being orbital refueling. Both have to work reliably before Starship can fulfill its purpose. And the heat shield challenge goes deeper than most people realize. Ship 39's heat shield contains more than 18,000 individual tiles. That number might increase as the design evolves and coverage expands. Managing a system of that scale introduces complexity at every stage. Manufacturing each tile with consistent quality, assembling them in the correct configuration, attaching them securely, monitoring them during flight, inspecting them after landing, and refurbishing or replacing damaged ones before the next mission. Now multiply that by dozens or hundreds of vehicles. That's the scale SpaceX is planning for. How do you maintain 18,000 tiles on 100 Starships? The math becomes staggering. 1.8 million tiles under management at any given time. Any inefficiency in the process becomes magnified across the entire fleet. That's why SpaceX needs manufacturing breakthroughs that make tile production faster and more uniform. They need assembly processes that reduce installation time. They need designs that simplify inspection and replacement. The goal isn't just building a heat shield that works, it's building one that scales to an interplanetary transportation system. The complexity beneath each tile adds another layer of challenge. These aren't simple ceramic plates bolted to the hull. Depending on the specific design, there may be multiple layers underneath: structural backing, active cooling channels, thermal barriers, the crunch wrap gap filling system. When each tile becomes a multi-component assembly, the entire system becomes exponentially more complicated to build, maintain, and repair. Simplifying these substructures without compromising performance. That's the engineering challenge SpaceX faces over the next few years. Can they create a heat shield that's both highly effective and operationally simple? The answer will determine how quickly they can scale from test flights to operational missions. Right now, We're watching the beginning of that answer take shape. Ship 39 represents SpaceX's best current solution to a problem that's plagued Starship since the beginning. The V3 heat shield might not be perfect, but it's a massive step forward from V2's visible struggles. When Flight 12 launches in January, most people will focus on whether Mechazilla catches the ship. That's understandable. It's visually spectacular, it's technically impressive, and it's never been done before. But the engineers at Starbase will be watching something else entirely. They'll be studying telemetry from those 18,000 tiles, monitoring temperatures, tracking any signs of coolant leaks or oxidation. Because catching the ship only matters if it comes back in condition to fly again quickly. That's what V3 is really about. Not just surviving reentry, but surviving it well enough that Starship becomes an operational vehicle rather than an experimental one. The heat shield separates those two futures. If it performs as designed, SpaceX moves one giant step closer to the rapid reusability that makes everything else possible. Moon bases, Mars colonies, point-to-point Earth travel, satellite deployment at costs nobody else can match. If it doesn't, then V4 will have to solve problems V3 couldn't. But based on what we're seeing with Ship 39, SpaceX believes they've cracked it this time. The next few months will prove whether that confidence is justified. So here's my question for you. What do you think will be the biggest surprise when Ship 39 flies? Will the heat shield exceed expectations, or will it reveal new challenges nobody predicted? Drop your thoughts in the comments. I read every single one. If this breakdown helped you understand what makes V3 different, hit that like button. Share this video with anyone following Starship's development, and subscribe to Space Update 24 hours so you don't miss Flight 12's coverage when it happens. This is the year Starship evolves from prototype to operational vehicle, and you'll want to see every moment. Thanks for watching, and remember, the future isn't written in boardrooms. It's built in places like Starbase, one tile at a time.